All right, dope. Did I say it? Did I use it right?
Yes, you did. Very good job.
Get a star for the day.
You get 1 gold star.
All right. Midterm exam. First of all, another reminder. Oh, hold on. I don't have my. It's recording. I just don't have my HDMI thing plugged in because you can't see my screen in here. All right. And just as a precautionary, I'm going to Zoom recording just in case the resolution change did something funky. All right. So first of all, as a reminder for the midterm, it's a week from today because we don't have class Thursday. Thursday we're on fall break. Okay, so the originally I did, and then somebody reminded me that it's fall break.
Okay.
So the related to the fall break, you probably saw the announcement from the university. They are encouraging you, giving strong guidance that you stay on campus or stay in the area over fall break. They're going to have some programming here, events and things like that for fun on campus stuff.
Programming events or what?
No. Like yeah. They're doing student life. Student life is doing stuff here. Who knows? Maybe the hackathon club will do some kind of get together or something like that. But just in general, they are scheduling some stuff. So there are things that you can do over break, and I think the cafeteria and all that stuff is going to remain open. So they're giving you strong guidance to stay on campus to try to prevent a mass exodus from campus and people coming back with, COVID and other things. So, but also keep in mind that nothing prohibits you from going home. You're allowed to come and go during the weekends and stuff anyways. So the guidance thing is more of a strong suggestion in hopes that keeps large swaths of the university going somewhere else, and we'll just see how it plays out. But so in any case, that will be so that's Thursday and Friday this week. So I think any classes after 4 p.m. Wednesday are not canceled, but won't meet because you have break. So if you have an evening class on Wednesday, I do not think it meets, but confirm that with your professor just to be sure. I think that's the official thing. Grad classes follow a different rule. So if you happen to be taking a graduate level class, because sometimes students take that like in the MBA program as electives or something, they don't follow the traditional undergrad schedule thing. So they actually don't have a fall break. So those classes still meet, but in any case, Thursday and Friday this week, you won't have any undergraduate classes. So the next time we'll meet is on Tuesday. So the exam is going to be during class time. It's going to be on Blackboard. So it'll be open at the beginning of class and it will close at the end of class. So you do need to take it during the class time. We won't meet in person because it's going to be on Blackboard, but I will be live during the exam on Slack or able to jump on Zoom real quick if you have a question. But if the exam, I doubt you'll have questions on, but I will be available for you to immediately ask a question and immediately get a response next Tuesday. So a week from today will be the exam. So what's that, Tuesday the 20th? Okay. So I will not show up to class here. I won't have a the Zoom class going, but I will be sitting at a computer with Slack open and able to answer any questions in real time if you have a question about the exam and what I'm asking or something like that. Okay, so most of you have seen my exams before, so you know the typical format, but I'll go over it again since not everybody has had my class before. So 10 questions, each worth 10 points. As always, there will be at least one conversion question. So that'll be something like convert from one base to another or from one size/speed to another. So I should be able to ask you things like, what is 272 from decimal to hexadecimal? Something like that. Or what's the 121 in octal is what value in binary? That kind of stuff. Similarly, I should be able to ask you if you have a 300 megabit per second internet connection, how long would it take you to download a 2 gigabyte file? That kind of stuff. So you should understand the difference between bits and bytes and be able to convert between those. Those are all things we did in 200. So for example, in that example there, I said a 300 megabit per second. So 300 megabit per second internet to download 2 gigabyte file. Well, so you can go a couple different directions here. You can decide how many megabits 2 gigabytes is. So you can say 2 gigabytes is equal to 2 times 8. So that gets you to gigabits. Times 1024 gets you to megabits. So 16,384 megabits. So 2 gigabytes is 2 times 1024. So if you want to go a different route there. So 2 gigabytes is equal to 2 times 8 gigabits. So that's 16 gigabits. To go from gigabits to megabits, you multiply it by 1024. So now you're at 16,384 megabits. So now if I have that and I can do 300 megabits per second, it's going to take me 54.6 seconds. So divided by 300 megabits per second is equal to, what did I say, 54.6 seconds. That's how long it'll take to download theoretically, to download a 2 gigabyte file at your maximum internet speed, for example. So there will be at least one question like that on the exam, probably only one question like that on this exam. And that statement is true on every exam you ever have with me. That's a skill that all computer scientists should have. They should be able to work between bits and bytes, and they should also be able to work between bases. Okay, so at least one conversion question. Then there will be at least 5 programming questions. And then the rest are short answer essay type things. No multiple choice, no true false. The 5 programming questions will not necessarily all be you writing code. It might be you looking at my code and telling me, what does this do? Okay, and remember that for those kinds of questions, I'm not asking you to give me a line by line. Well, this is a for loop that says I does this. I'm defining a variable that does this. When I'm asking, you can do that, but what I'm ultimately asking you to do is tell me as a whole, what does this code accomplish? You know, what problem am I solving with these 19 lines of code or something like that? You know, I'm summing up all the odd numbers between 1 and 1,000, something like that. All right, that makes some sense? Okay, let me put my, Okay, so what I'm going to do is I'm going to go back to the beginning of the slide set here, and I'm going to go through and I'll point out the areas that I think are things that you should focus on for the exam. If you remember, as we kind of go through things during the semester, I pointed out, so, oh, this is more trivia knowledge, not something I'll necessarily test you on, but I'll reiterate that so you kind of know what to focus on as you're studying for this exam. Okay. You know, certainly, again, appreciate this idea of how do human beings solve problems. I would not ask you this question directly in here, but keep in mind that all programming languages provide you facilities for these things, and that's kind of our foundation for how we learn programming. Let's see. What does a compiler do? Is would be fair game. We do want to remember that what language do we use in here? Java? Yeah. So we want to, I get confused with it. My next class is Scheme. My last class was Python. So we want to remember that Java is a compiled language. And what does that imply? That implies that our high-level code goes through a compiler and gets turned into low-level code. Specifically with Java, it ultimately runs on a Java virtual machine. So there would be a chance that there will be a question about that, because that is an important core truth of the Java language, is that it ultimately runs on a virtual machine that is portable, right? Ones run anywhere. But ultimately, you still use a Java compiler as opposed to an interpreter like we used in Python that will convert our language from high-level Java code into low-level bytecode that is capable of running on the software-based CPU that is the Java virtual machine. All right, so understand that for a compiler, the generalistic compiler, we require two things: the target architecture, what kind of CPU are we targeting, and the operating system. Remember, we looked at Hello World for Linux, I think, in here, where it still used some magic tricks from the Linux operating system, where it called the Linux operating system's system call to write stuff to the screen, that kind of stuff. So, you know, we want to understand the nature of a compiler, where it is taking your code and targeting it for a specific computer as well as a specific operating system. I probably would not ask a question that gets too deep into that topic, but you should be very familiar with compilers, specifically the idea that Java uses a compiler that turns your Java code into bytecode for the Java virtual machine. So this would fall into that same category. I wouldn't spend too many questions on this stuff, but understand that Java does run on a virtual machine. You know, you write your code once, it will run on any platform that supports the Java virtual machine. You know, here's kind of our pipeline of the life cycle of a Java program. So understand how your Java program ultimately runs on your computer, something along those lines. You should be able to write a Hello World program, an error-free Hello World program in Java. Pretty good chance that I will ask that question. So write an error-free Hello World program in Java. So this guy should have this memorized. Okay. I'm not necessarily a huge advocate of just, you know, memorizing everything, but this is one of those go-to moves. You know, any language that you go and learn, you should memorize the core Hello World program in that language, so that whenever you have to go write code for that language, you can just give yourself an initial working program in that language that you can then build the rest of your code out of. Go ahead.
I'm guessing the answer is no, but can we use like Eclipse to format
I'm fine with that. So the question was, can you use Eclipse to format your code? Really, so this would be my official response. I'm perfectly fine with that. using Eclipse to format your code or using any other text editor or something like that, that's all fine. Officially, I'll say it's closed book, closed note, closed neighbor, can't use Google. You can use a calculator, but I'm not going to sit there and waste any of my time looking for cheating. So, you got to look yourself in the mirror. And you're spending a lot of money on college, right? So you don't want to graduate, not have any skills, and then go get fired from your job. I get paid either way, and I want to make sure that I teach those of you who really care about learning, and if you want to find shortcuts or find a way to get through the class, frankly, I don't care. I'm not going to sit there and try to police it. Just use your own choice. Don't cheat. I would say putting code into Eclipse and making sure it's formatted, that's not cheating. I would say don't run the program, but also at the same time, because I'm not expecting you to run your code, I'm not grading it with, a fine tooth comb and you forget a semicolon, you're losing half credit. Programming is a pretty easy thing to grade. It's pretty clear when I look at some code to know, does this person pretty much know what they're doing, or do they pretty much not have a clue? It's usually one of those two. So, very often you might write something that gives me a little bit different thing than I asked for, but it was like an understandable misinterpretation of the question, but you showed me that you know what you're doing. I'll knock you for a point or something like that, just for, getting confused on what I was asking, as long as you're like, well, I thought you were asking for hello world, but I was actually asking for something way more complicated. But, in general, my job is to give you a grade based on how well you've mastered the material at the end of the class, right? So, I'm not nitpicking on a forgotten semicolon. Eclipse will be happy to scream at you about that. Just through practice, you're going to get better at that. But anything you want to do on the exam that you think will make your life easier using a text editor for formatting or something like that, that's fine. Also remember that I have the same policy as I do in my other classes, where if you do better on the final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you get on the final. So, you get a free get out of jail free card, where if you bomb the midterm, that means you haven't really been, doing the stuff yourself. You've been relying on classmates for getting your homework done, which I encourage you to work in groups, but don't just turn in somebody else's code. Again, doesn't matter to me. You're only hurting yourself, right? So, hopefully that gives you a wake-up call. If you don't quite know what you should know by this point, and you come into the exam and you get a 20% on it or something, well, then okay, I need to maybe take a little bit more ownership of my own work and work in groups, but don't necessarily let the group do my homework for me. I need to get more out of those group activities. All right, other questions about that side of things? So I would say, as long as you think it's not cheating, you can do it. That would be my take. Similarly, if on the exam, and I would actually recommend this, let's say you're on the exam and I'm asking a question about something and you just have a complete, a brain fart or something, where you're just like, I can't remember. I know I should know this, but I can't remember it. Just peek real quick, get your mind reset for what I'm asking you to do, and then give me an answer based on what you know. So don't copy it down from your notes, but I'd rather you not get a poor grade on the exam because you just had a little, memory blip, where if you can just peek at your notes real quick and say, oh, that's right, then you're right back on track. I'd rather see what you can do than, caffeine just hadn't kicked in yet or something like that. Yeah, right. So, again, to me, that's not cheating. I want to know what your brain is capable of, and it sometimes takes a little nudge. I'm okay with that. Just don't, open up your notes and then just spend the rest of the exam in your notes and copying everything down. So, use your best judgment. I want to know what you're capable of, not necessarily in the moment did you remember every little thing. My strategy when I was a student on exams is I'd have like this little sheet I'd write before every exam that kind of doing what I'm doing right now for you. I would go through all the notes in the class and decide, what do I think is important? And I would look at that like right before the exam And then at the beginning of the exam, I get into the exam, I write all the important stuff at the very top of the exam and just do this memory dump to the top of the exam. And then I kind of have open notes for the, the 4 or 5 things that like are memorization stuff. I would just put them on, I write them on the exam because I had them memorized. Okay. But again, be able to write a hello world program in Java error-free. And that's something that goes across the board for any language. That way, whenever you are asked to do something in some, obscure language you maybe haven't looked at in, 12 years or something like that, it's not a big deal. You should be able to sit down and write hello world in there, and that should bring enough back. So anytime you learn a new language, memorize the structure of what a program in that language looks like. If you don't want it to be hello world, you want it to be something else, that's fine. Just be able to write a structured template for that language. Okay. You should kind of know where Java fits in the world of language types here. We are dealing with a high level, compiled, strongly typed. So one of the things we've kind of focused on this semester so far is that difference between Python and Java, in that Java is strongly typed and we have to specify the kind of value that we're going to store in a variable. General purpose, less important. Object-oriented, important, but that should be fairly common knowledge for us now. We're doing everything in terms of objects in Java at this point. You should understand the nature of the CPU. Maybe not something I would test you on. I'd call it a relatively low chance. That's more of a 200 concept, that idea that the CPU is a collection of magic tricks that you call in a certain order, but that should be something that you're familiar with, and if it comes up in a alternate form in some question or something, maybe dealing with a compiling question or something like that, it shouldn't be something that you are ignorant of. So here's that kind of slide. Where does Java fit? So know about the tool you're using. I may or may not ask. I probably wouldn't ask a very direct question on that. Like I wouldn't ask you just regurgitate this slide. Again, I'm not a big fan of like just memorization, but you have a pretty good idea of where Java fits in the world of programming stuff. Know the primitive types we have available to us. I probably would not ask you questions about, how many bits is an integer in Java or something like that. Interesting, important, not something that is overly helpful to have you memorize or something. But certainly you should be familiar using integers and longs and chars and doubles and booleans. I'm not going to ask you any question with bytes and shorts or floats. Not that they're not important, they're just not commonly used. And there's a pretty good chance I won't have anything that deals with a long on the exam either. It's just a giant integer. So know the primitive types that you've used commonly. All right. The rationale behind the way of holding so many integers, I probably wouldn't ask about that, but that is something you should know, that whole Y2K thing and that kind of stuff. It's more of a 200 question. You should be familiar with Unicode. Why are characters represented as integers? I don't know if I'd ask something very direct about that, but it's possible that concept might show up in one way or another. I'd call it a low chance, but possible, that technically chars are stored as integer types, and they map to the Unicode character set. Be able to define variables, be able to work with strings. So you should be comfortable using char, add, index of, all the different string methods that we've commonly used. If there's a string method that I want you to use that I did not that we either haven't used often. Like you should know char at and index of. I don't have to give you those. But if I want you to use a method that either we haven't done before, I might even invent a method and just tell you that strings have access to this or something. You should be able to read a method definition and know how to call it. So if I make it a non-static method, that means it's an instance method. You call it using an instance of the class. If I say it's part of the string class and this is what it does, you should be able to call that method. That make sense? So this is all related to the stuff we've been talking more recently. We're being able to read documentation. So one of the things you don't want to rely on in programming is memorizing documentation. The reason we have documentation is so that you can go and reference it, right? You know, I've been programming in Java since the language came out. And yet I think that I've probably used less than 20%, probably even less than that of the language. There's all sorts of stuff in the documentation that I've never had a need to use. So this real skill is being able to go and look at documentation and call stuff. So I might completely make up a function that isn't even part of the string class in reality, but I might tell you on the exam, there's a method in the string class that's defined like this, and this is what that method does, and you might have to write some code that uses that method. Make sense? So you should know how to call a method, whether it's a class method or an instance method, and you know, if it returns an int and the integer it returns is of this nature, you should be able to use it. So one of the things that I will have on the exam in one way or one format or another is going to be the idea of being able to read documentation. Whether I give you something real or I make something up. I'd probably try to give you something real, but if I'm in a pinch and I needed to do something very specific to make the maybe the question a little bit shorter to write, I might make up a method and just tell you this is what the method does. Be familiar with the Boolean operators, ands and ors. You do not need to know about the bitwise operators though. So that and or, the bitwise operators, I think I've kind of shown you, oh here, yeah, this guy. You know, interesting. Most of you are probably taking CSC250 next semester, which is computer organization and architecture. In there, you'll be working with a lot of this kind of stuff. This is kind of dealing with the stuff that's happening inside of, inside the motherboard of your computer. The CPU communicating with system memory and the system hard drive, and what actually happens inside the CPU with the different hardware registers. That's where some of this bitwise stuff and shifting stuff occurs. Not something I'm going to test you on in here. Yeah, this is that bit shift stuff, just as I just kind of threw it out there as if you ever see this kind of stuff, this is what it's doing, but it's not a topic that's important to us in here in terms of when will we use it. Be able to work with arrays. So notice that arrays are different than lists. Lists in Python, you just define them. Lists in Python are kind of like array lists, which we've used more recently in Java, where they can grow and shrink as you add or remove stuff from them, but you don't need to define them to be a fixed size initially. Where in Java, arrays are a primitive type that when you define them, they will have a size associated with them because it will grab a plot of land in system memory to house the entire collection of that array, and it's stored in contiguous memory, so memory in a row. That's this guy right here. All right, so be able to define an array, be able to work with an array, fill it up with stuff, loop through it. I probably will not ask you questions about the contiguous nature of arrays in terms of memory. It's important, but not something I necessarily, I'm getting much more, when I'm writing an exam, I'm testing you over the stuff I hope that you gain competence in by doing the homework assignments. So while there might be some theoretical stuff under the hood that is important, I don't want you to lose track of what I'm really trying to get from you, and also because of the policy that you can replace the midterm with your final, I really want you to become aware of whether or not you're getting as much out of the homework assignments as you should be. And part of that is keeping the exam as much of applied stuff as possible instead of kind of under the hood detail-y stuff. All right, so this slide I would say is important in the big scheme of things, but the most important part of it for the exam is be able to define an array that can hold 5 integers and then do stuff with it. Okay, so the syntax of using arrays. Be able to write if statements. You know, again, this is kind of our time when we were converting between Python and Java. So all the stuff that you could do in Python, you should now be able to do in Java and understand those nuances between the Java syntax and the Python syntax. Again, on the exam, if you miss a little stupid curly brace or something like that, I'm not going to kill you on points, but it's pretty easy to tell whether somebody mostly knows what they're doing or mostly does not know what they're doing. All right. So I'm not going to give you partial credit because you had the word int somewhere in your gibberish. All right. Show me that you know what you're doing. Plus, plus, minus, minus. I'm not going to ask you a question about the specific nuances of that. You should know it. You should know what the plus plus comes first. It iterates, it increments at first and then gives you the new value. If it comes after, it gives you the new current value and then it increments it. But not some, I mean, if you just want to always write stuff as a equals a plus 2, that's fine. I'm not gonna give you a question and say you have to use the plus plus or the minus minus operator for this. And I won't ask you specifics on the exam. You should know that stuff with how the plus plus and minus minus works, because that's part of being able to read other people's code and being able to read other people's documentation. But if I give you a code on the exam and I say, what does this code do? I won't try to trick you with plus plus or minus minus being before or after. I want you to be able to tell me, can you generally read code? Be able to use the scanner for reading in from the user or for file IO. If I might use it as code that you have to read and tell me what this does. Otherwise, I might, let's say on the exam, I want you to read something in from a file and then do something with it. I might tell you there already exists a method that that when called will give you the contents of a file named input.dat or something like that. And then I want you to do something with the contents of that file. So I would make the assumption that you could look at your documentation and do file IO if you had to, but from a time perspective on an exam, I might say, this guy will give you an array of strings where each string is a line read in from this file. And the lines look a certain way. And then from there, you might need to split it up, do something with them, that kind of stuff. So I would try to pay attention to how long something might take you to write on an exam and try to give you some shortcuts for that. But again, that is still testing that idea of, can you read documentation? And if somebody hands you a tool that does something, can you use it? Even if I made up the tool. So there was a conversion thing, be able to do those. For each loop, we haven't worked with them that much. It's possible I might write some code that you should be able to read that uses a for each loop, but I wouldn't give you a question where you absolutely had to use a for each loop. You know, there will be, so when I ask you to write code that does something, unless I have a really, really, really good reason, I probably would not pigeonhole you into saying you have to do it a certain way. You know, sometimes it might say you have to use the random class for generating an integer or something like that. But generally speaking, if you like while loops better than for loops and you want to accomplish your problem that way, that's fine. I won't lock you into a certain syntax. Definitely be able to do integer division versus modulus. So in Python, we had that choice to do, Python default division is floating point division. And if you wanted to force integer division, you had to use a double slash. In Java, the default division is just normal division. You would have to force it to do floating point division otherwise. But know the modulus operator, be able to do that kind of stuff. Definitely be familiar with the idea of using the double equal sign with strings as actually comparing their memory addresses, not their contents. So you have to use dot equals for comparing their actual contents. Be able to write functions. Pretty much any of the coding questions I ask you to write is going to be write a function that takes some kind of parameter and does something. So be able to do those things. Be able to write a simple class. We're just now starting to get into classes that start doing more complex stuff, but you certainly should be able to represent things using a Java class. So here's an example of like a dice class, and you know, here's creating a class, here's using the class. Member security, definitely something important. Public, private versus protected. I probably won't ask you much about protected since we haven't done inheritance yet, but certainly the idea is if you have a private class member, what's the role of getters and setters? That would be a kind of thing that you should know about. Certainly static versus non-static methods. When you're defining them versus when you're calling them, again, this should be something you have memorized. You know, and that's going to be on the exam one form or another, maybe even for a couple of questions. You know, I can't emphasize enough how important it is to be crystal clear on that idea of static versus non-static when you're looking at the definition versus when you're seeing it being used, because that unlocks the entire documentation to you. And I'm going to expect that you have that competency on the exam when I give you methods and say, assuming there's a tool that's method definition looks like this, you should be able to call it the correct way. File IO, I probably won't have you write code specifically that does file IO from a time perspective, but certainly string manipulation stuff is going to be important. So if I say, you know, we've read in from a file a bunch of strings separated by colons or something like that, you should be able to use the split function to get them split up into an array of strings and then work with them. Using array lists with generics, I would say is something you should be able to do. You should be able to read that code. You should be able to write code with it. I won't ask anything about big O notation. This is more of a, I mean, we've only briefly talked about it anyways, but this is more of a comparison of algorithm performance, like kind of like if we think about it in real life and we're asking, you know, which car can go faster? We measure it in terms of miles per hour or something like that. Well, in computing, we measure it using a big O value. You know, which kind of the shorthand version of that is the average number of comparisons that needs to be done when this algorithm is run. Tells us what's fast and what's less fast. Realistically, though, and you've heard me say this before, these things in the big scheme of things are less important today than they've ever been because our computers are so fast. That doesn't mean they're not still important. They're just only important in very specific situations when you're working with data whose nature is such that efficiency is really important. And we do need to consider how long this is going to take to run, whether that's in a video game or something with data science where we're working with giant data sets. We have one of our seniors right now, Jack Michaelatz, who's working on an artificial intelligence project. It actually sounds like it's going to be really funny. Working with a huge data set, and depending on what the inputs are, it uses Bernie Sanders' voice to say stuff back. But it, you know, he's having to train this on a machine with several GPUs in it, and it, you know, it's going to take like multiple days to train that neural network. So I mean, it's those things need to be higher performance. Pay attention to complexity and efficiency and those types of things. where for us, most of the problems we solve, if we wrote it in the worst possible correct way versus the best possible correct way, it's going to feel like it happened instantaneously to us, right? That's going to be a majority of the problems that we solve in real life. Okay, and then we're just starting to get into the sorting algorithm stuff. So most of that is going to be handled in the second half of the semester, on the final exam. So even though we've looked at a couple of searches and sorts already, I won't actually test you on those. Like you won't have to memorize, what have we actually done already? A selection sort?
Insertion.
Oh, insertion sort, okay. Yeah, I mean, you don't have to memorize any of those algorithms or anything like that for the exam. I suppose it would be fair game for me to write one of them and put it as like, what does this code do? And you should be able to read it and tell me, but you don't have to memorize it. You wouldn't have to say, oh, this is a selection sort. You could just say, oh, this sorts the data. That's what you're going to ask. Yeah. You wouldn't have to recognize one of the algorithms in the wild at this point. You know, but if I give you code that one way or another sorts some data, you should be able to tell me that sorts the data. Okay, so I think that pretty much gets us to polymorphism could make a appearance on there. That's the idea of having more than one method with a different name and or type of parameter. We've seen it with like the println method. Systems.out.println. There's a whole bunch of different versions of println to handle all the different primitive types as well as strings, and then the catch-all is for objects. Technically, you should be able to write a linear search. It's not really an algorithm to that. It's here's a list, go through it one bucket at a time looking for a value. You don't have to think of it as a linear search, but that's code that you should be able to write. But then we start getting into these, which we've written more recently, and you won't have to write those or really know anything about them at this point. That's going to be more a second half of the semester. Okay. So, questions about the exam?
I have one.
Sure, go ahead.
On the topic of polymorphism, one of our programs we had before had multiple constructors with the same name. Is that an example of polymorphism, yes or no?
Yeah. Yes or no? It's like
maybe.
It's like, well, I'm going to choose to not answer that question, and yeah, that would be. It's probably It's a good example of polymorphism. It does actually deviate from my definition of it, more than one method, since constructors technically aren't methods, but it's polymorphism. I would never ask a question like, you know, here's 12 lines, tell me which ones are examples of polymorphisms and which ones are not. You know, it's not my style for questions. You know, you should understand the concept of polymorphism from the perspective of, you might write two methods that have the identical name, but maybe they accomplish different things. So like the example he referenced there was when we had our constructor for reading the stuff in from our file. We had one that took in the 3 pieces of information for our Bible book. We had another one that took in a string format that we had read directly in from the file, and it went ahead and split it apart for us so that we could have that all kind of hidden inside of the objects constructor. It just did the magic for us. So both of those are viable ways of constructing a Bible book object, but they had the same identical name, but they took a different number and or type of parameter. One took a string, the other one took a string and an int for number of chapters, like something like that. So yeah, that would be an example of polymorphism. Okay, other questions or anything you want me to go back and review or giving you a code example of or something like that? Okay, so then let's look at our homework assignment. So this is what we had due for today, right? So we had our updated solution to homework 7 that has our Bible book collection. And then we were supposed to add a sort on name method, which sorts itself on the book name alphabetically. And then add a sort on chapter count, which sorts it on chapters. Add a display method, which displays the entire collection in its sorted state. Okay, we have to use a bubble sort to accomplish it. And then I gave you a hint that the compare to method for comparing strings to each other might be handy as we do this. Okay, so first of all, if we go back and look at BubbleSort here, how does BubbleSort work? So BubbleSort continually swaps the adjacent elements if they are in the wrong order. So we just make multiple passes through our code until we don't do any swaps. So this first one, if we just kind of cover BubbleSort here quickly, if our data looks like this, 5, 1, 4, 2, 8, well, as we're walking through, we'll swap the 1 and the 5. You know, but then we keep going down through the line. We check the 5 and the 4. We swap the 5 and the 4. We keep going down the line, 5 and the 2. We swap the 5 and the 2. Keep going down the line, 5 and the 8. We swap the 5 and the 8. Actually, we don't swap the 5 and the 8. We leave them alone. Okay, so that was our first pass. We say we did some swapping. We're going to have to make another pass. Start again. Second pass, 1 and the 4, no change. 4 and the 2, no. 4 and the 2, yes, there was a change. We did a swap, so we kept track of our number of swaps, right? Then 4 and the 5, no swap. 5 and the 8, no swap. We finish doing that pass. We say, how many swaps do we have? We had 1. We're not confident that it's sorted yet. Do our third pass. 1 and the 2, no swap. 2 and the 4, no swap. 4 and the 5, no swap. 5 and the 8, no swap. How many swaps do we have? 0. It's sorted. Make sense how BubbleSort works? All right, so seems to be maybe this isn't our highest performance sort in the world, right? We just kind of keep going through we keep performing the same step where we're gonna, you know, swap, keep walking through a thing and checking something against the guy that's right after him and swapping and just counting the number of swaps we actually had to do. And we're gonna keep doing that process over and over and over and over again until we have 0 swaps. Then we can just say, I tried everything. It's in the right order. Okay, so that's what a bubble sort is. So let's go and look where we left off. Just my clips here. Okay, what do I currently have? So I can create my Bible book collection. I read in from my data.dat that I stole from Emily that she stole from somebody else, I think. Stole from you? Then we are showing our searching from our searching the summaries that we had for our class last time. Okay, so now we're going to update this this thing. So we are adding a sort on name method, which sorts itself on book name. Okay, so first of all, let's go ahead and let's write on sort on chapter count. First of all, that'll give us our numeric bubble sort, right? Because that's the, well, first of all, I give you an example on that. I think I give you an example of that, don't I? Yeah. So here's a bubble sort example of for doing numbers stuff, but we're going to go ahead and we're going to not look at that when we write this. All right, because this will be kind of good practice for the exam, not so much from a bubble sort perspective, but just from an algorithm perspective. Writing stuff, we're keeping a count of the number of swaps and that kind of jazz. Okay, so we're going to go into our code here. We're going to go into our Bible book collection. Our Bible book collection has this array list that has kept a, you know, it has a collection of all of our Bible books in it. All right, so we have 2 different objects at play here. We have Bible book collection, which maintains an array list of Bible books, And then we have a Bible book, which maintains which represent an individual Bible book in terms of its name, its number of chapters, and its summary. Okay. And what we want to be able to do here in this assignment is we want to be able to ask a Bible book collection to sort itself based on the number of chapters, for example, with the smallest number of chapters coming first, largest number of chapters coming second, well, coming at the end. All right. Now, I think the question came up last time is, should we be able to, because once we sort it, we've lost the original order, right? And I said it doesn't necessarily matter for this assignment. You can always decide to preserve that. But for right now, we're just going to say the order of the books is unimportant. So once we tell it to sort itself on chapters, we're probably going to have a different order. That's just going to be the way it is. But what I'm going to do just as a starting point, I think I already have, do Bible books have the ability to display themselves in a reasonable way? Yeah, they do. So why don't we go ahead and, do I have the same way to do it for a Bible book collection? I don't. So I'm going to go ahead and just write a display for Bible book collection real quick. That way we can conveniently spit out our whole collection and see, did our sort work? Okay. So we're going to have a public void display for our Bible book collection. So I'm inside of Bible book collection here. And this guy is going to go through each of our Bible books that's in our array list. So I'll say for Bible book B in this dot the books. So array lists are iterable, so we can use a for each loop for those. You don't have to, but you could. And then we'll just say B dot display. So this will go through each of our Bible books in the books and ask each of those guys to display themselves. We'll go ahead and test this guy real quick. So we'll say the New Testament dot display, and we should get all of our books displayed to the screen in terms of the number of chapters and all that jazz. Okay, so that is our unsorted list. So now we have the ability to look at our Bible book collection. So now we want to go ahead and we want to write a, inside a Bible book collection, we're going to write a sort. And just to be explicit here, I'm going to say public void bubble sort on number of chapters. And this guy's job will be to sort the books on chapter count from smallest to largest. Okay, so as we go through this, we want to have our algorithm that goes through our list and swaps when we need to swap, right? And remember, the list we're going through is a collection of Bible books. It's not a collection of numbers. The example I gave you in the slides here, this BubbleSort just goes through a collection of numbers, right? This is a collection of Bible books, each of which has a number. So you got to go one more level in to get your number portion of this. Okay, so let's think about doing a single pass. So what did we do? We started at bucket 1 and we said, does this need to be, we'll start at bucket 0. Does this need to be swapped with bucket 1? Then we followed that guy regardless of whether we swapped or not. Does bucket 1 need to be swapped with 2? Does bucket 2 need to be swapped with 3? All the way up to and including the guy right before the last one, right? Because if I get to the last element in there and I say, should he be swapped with the next one's in the illegal position. Okay, so I need to have a loop that's going to take me through all of the indexes from 0 to the second to last index. So for int I is equal to 0, I is less than this dot the books dot size minus 1, I plus plus. All right, so that for loop will take I on a journey from 0 to 1 to 2 to 3, all the way up to the bucket that comes right before the last legal bucket. All right, then each time through, we're going to ask, should we swap? Should we swap bucket I with bucket I plus 1? That's the question we want to ask here. So we'll ask the question. We're out at 1250, correct? Okay, thank you. I have to adjust coding speed based on how desperate we are to the end of class. All right, so we're going to ask the question, should the current bucket we're looking at, bucket I, be swapped with bucket I plus 1? So we're going to say if this dot the books dot get I, that guy is a Bible book, right? And Bible books have a get number of chapters getter. So I'm saying, is the number of chapters from the Bible book at bucket I, is that greater than? So I only want to swap it if it's bigger than the next guy, right? If that's greater than this dot the books at bucket I plus 1 dot get number of chapters, that means I should do a swap, correct? All right, so I'm going to give myself a temporary variable for handling my swap. So I'm going to say Bible book temp up here. And then I'll go ahead and say temp is equal to this dot the books dot get I. And then I'll say this dot the books dot set. I'm going to set an index. Let's see, I'm trying to think. Are we going to have to remove both of these? I guess we'll see here pretty quick. So I'm going to set index I plus 1 actually we'll set I equal to this dot the books dot get I plus 1. So I'll replace bucket I with bucket I plus 1. And then I'm going to say this dot the books dot set bucket I plus 1 with temp. I'm going to have to look at how get and set work for array lists to see if this does swap them or if I'll have to remove the two and then put them back in the right place. But this looks reasonable enough. So preserve bucket I, overwrite bucket I with bucket I plus 1, then overwrite bucket I plus 1 with what used to be at bucket I. So that will do my swap. But now, anytime I swap, number of swaps, I'm going to start that guy off at 0, actually. I'll just initialize him to 0 inside the loop here. We'll do that here, actually. So number of swaps starts off at 0. If I do a swap, we'll say number of swaps plus plus. Now, this makes a single pass through all of our books, okay? Swapping wherever we should be swapping. So if I want to, I can go ahead and actually run this once now and just see if some swaps occurred. We should see that right at the get-go, we should see a swap between 28 and 16. These guys should swap. So let's go ahead and let's test just our initial pass. So we'll say the New Testament dot BubbleSort on number of chapters, and then we'll say the New Testament dot display. And here I'll actually not display the first one just since we've already seen it. So we got a yeah, looks like we got some swaps. Looks like it worked reasonably. I don't have duplicates of any of my books. So we'll call that so far so good. All right. So this makes a single pass. Now, how long are we going to keep making passes? Well, as long as number of swaps is not equal to 0. So what I'll actually do is I'm going to initialize it to -1 at first. Then I'll say while number of swaps, and I didn't have to initialize it to -1. Say while it's, in fact, actually, well, while it's not equal to 0, let's do some stuff. The first thing I'm going to do is I'm going to reset it to 0. Then we'll take this entire for loop and we'll put it inside of that while loop. So start number of swaps off at 0, make a pass. We'll spin back up. If number of swaps is something other than 0, we need to do it again. So there's our Philemon, 1 chapter, 1 chapter, 1 chapter, 3, 3, 3, 4, 4, blah, blah, blah. Looks like it's sorted. So we kept doing those passes over and over and over again, as long as number of swaps was something other than 0. I zeroed it out. The only time that guy changed was inside if I had to do a swap. So that very last time through, I never got into this if statement, which means that this last pass, when I was done with this last pass, number of swaps was still equal to 0. Came back up, is number of swaps not equal to 0? That's a false statement. So I fall past it, and now the sorting is done. Method ends. Make sense? All right, so that's our bubble sort on number of chapters. Now we're supposed to also have a bubble sort for, what is it, the name? So we'll say bubble sort on book name. So we'll do pretty much the same algorithm here, except we're not comparing the number of chapters. Instead, we're comparing the name. So we're going to say if, now we have to go look at the compare to method. The compare to method returns a 0 if 2 strings are the same. It returns something that's less than 0 if the first element should come before the second element. And it returns a value of greater than 0 if the first element should come after the second element. So what I want to do is I want to say, I'm going to get the book name, get name, and I want to compare that to the other book name. All right, and that's going to give me a value of something smaller than 0, something equal to 0, or something greater than 0. I want to do a swap if it's greater than 0. So if, let's see, get book, get name, there's the name I come here too. Okay, so if the book I'm currently looking at's name, when compared to the next book's name, gives me something greater than 0, that means I need to do a swap. That means that the first book comes after the second book alphabetically. It's actually something called lexigraphically, but we'll call it alphabetically. All right. Because it'll also look at like punctuation and anything with Unicode. Okay. So if that's true, we'll do our swap, keep track of our number of swaps. So this is BubbleSort on book name. That is. Oh, because of the, I was looking at, why are there C's down here? Yeah. This is the lexicographic one that does the numerics too. So X, yeah, so that does our BubbleSort on the book names. Okay, what else are we supposed to do here? Oh, that's it? That's done. Okay, so what's up? Okay. All right, so any questions on that? So we made all our updates to our Bible book collection. We saw what a BubbleSort looked like. Now, what's important here is, and let's just give you a little bit of, we're going to spend the second half of the semester looking at searches and sorts in a lot more detail, but we can look at something like a BubbleSort and say, okay, this is one way of accomplishing sorting a bunch of stuff. Now we could look at that and say, well, that didn't seem like maybe the best way of doing it, but it seemed like a pretty straightforward way of doing it, right? You know, I'm just going to keep swapping stuff until I go through it and didn't have to swap anything. That seems to be something that a human being could pull off. And the fact that computers are really fast, that's something we can rely on being able to just kind of do. No big deal. So with that in mind, is it important for us to, let's say 5 years from now, you're looking at some code and it's a BubbleSort. Is it important that you could say, oh, that's a BubbleSort? Or if somebody says, write a BubbleSort that does something, you know, do you think if you're at work, they're going to say specifically to write a BubbleSort that does something? Or do you think that's probably not what reality is like? Reality is probably like you're going to call some built-in sort method that's built into the language that's probably using, by today's standards, they're probably using either a real quick sort or a modified quick sort, which is considered to be a, as the name implies, a quick sort. But it's not overly important that we know the names of these sorts. Academically, being able to tell the difference of them and we can give names to it, I think that could be important. But really what we're looking at here is various algorithms, various approaches to sorting data. So we can almost look at this like a recipes for a lasagna. You know, you can get 50, 60 different recipes out there on the internet, probably more than that, but you know, just use that as the number. And instead of us judging them on which one was the fastest to make, although that sometimes is what we care about, what can we get done in an hour or something, you know, we judge them on which one tastes the best, something like that. Okay. And so we're really looking at something fairly similar to that. It doesn't matter what lasagna recipe 1 was named versus lasagna recipe 2. That's more of a historic context for us, maybe something for us to be able to reference these kind of known sorting algorithms. But I would probably never ask you on an exam, I wouldn't give you code and say, which sort is this? You know, based on the code. Now, when you get into the 491 or 490 class, the theoretical computer science class, if you're a software engineering concentration major, one of the things they do in there is they focus on the big O notation of some of these things. So, and we'll talk about it in here as well, where it might be important to say, well, what's the big O notation of BubbleSort? Or what's the big O notation of insertion sort? You know, because that allows you to compare one to another. Modernly, that's not that much of an important applied skill set. Historical, theoretical computer science, it might be somewhat important, but it's something I won't test you on in here. All right, so remember, exam is next Tuesday. We do not meet in class on Thursday because we're on fall break. The exam will be on Blackboard. It'll open up at the beginning of class. It'll close at the end of class, so make sure you wake up to take your exam during class. We will not meet during class, but I will be live at a computer to answer any questions during class that you may have about a question I'm asking on the exam or something like that. Questions, comments, concerns, bribes. Go ahead. No homework. Yeah, study for the exam. And enjoy break and study for the exam. Combination of those two. Anything else? All right, I will see everybody on Thursday, but I might talk to some of you on Tuesday. Hopefully not too many, but I'll be available to talk to you on Tuesday.
Have a good one.
Yep, take care.